Okay, good morning, everybody. Welcome to the morning session for Next Big Thing. This is novel applications of data. Exits are as you came, so in the back, there's also exits on the side. This session and each of our three presenters will be recorded, so please know that everybody is at least indirectly on camera. I'd like to invite all of you. We have a reception tonight, a reception hosted by our sponsors that you can see above here. And also, if some of you see some QR codes on cards on your seats right now, and you have a second, please do take a moment, click on that link, and fill out a short survey that we have on various AI applications. Okay, during each one of our talks, we will also have a second QR code for asking your questions. So we're going to hold all of our questions until the end of the session. I will be collecting them on our Slido app, and then we'll be addressing the questions to our speakers at the end of each session. Okay, our first presenter is Hannes Walter. Hannes is VP of Product for 3D simulation environments at Blackshark.ai, building a 3D twin for global simulation. Before joining Blackshark, he led business development for professional XR software solutions at Austria's largest ICT integrator. He holds a Master of Science in Media and Interaction Design, is trained in electronics, and has worked as a 3D CAD, product manager, and business consultant. At Blackshark AI, Hannes directs the strategic product roadmap for the 3D simulation environments and hard and software solutions. Please welcome Hannes.
Can we go to the next slide? Or okay, great. Good morning, everyone. Yeah, as you might hear from my accent, I'm from Austria, Graz. This is Salzburg in Austria. As one part of our 3D twin of the globe, we did this for the entire globe for the Microsoft Flight Simulator 2021. And our platform and technology is still part of the latest release, which was released a couple of weeks ago. The purpose back then was, of course, not to train autonomous systems based on synthetic data. This will be the topic of my talk here. For this, it was, or for the Microsoft Flight Simulator, the purpose was to provide an as realistic, immersive 3D twin of the globe so that everyone can fly around, land, take off, and so on. But we are at the dawn of autonomous systems. Everything that can be autonomous will be potentially autonomous in the future. And those autonomous systems need to be trained. We want to have robust, reliable autonomous systems interacting with our world, with us. So this is important for us as individuals, as society, as nations, as mankind, basically, because we want to avoid the Terminator situation. So we really want to train it in a good way and right way, in a reliable way. And this needs training data. Just like a human experiences and senses the environment with the eyes, the ears, and so on, the autonomous systems or robotic systems experience their environment with their sensors, with cameras, acoustic sensors, and so on. And just as we as a human or as humans and child train our brain based on all kinds of experiences, we need to train those autonomous systems how to interact and how to react to certain situations. And this needs training data. For us, when we train our brain, we have the real world and the feedback of our environment, of our parents, and so on. But for autonomous systems, we need to find a different way. We could, of course, train this on real-world data. So imagine we take a picture of or out of a car, and then provide the information to the autonomous systems what is seen in this scene or in the image. And for this, we need a machine-readable version of the globe. This is the essential piece here. So we can very flexibly interpret and understand what is seen based on our experience, but those robotic systems need to be trained so that they see or they know what is seen in the sensor data. Imagine again this picture, and we draw a border around the car in front of us. Then we have the so-called segmentation mask for this car. And so, okay, this is a car, and we can pass this on to the system. And you also need to provide the metadata, the attribution, saying this is a car. And we want to have this for everything on this picture. We want to understand this is a lamppost, this is a hydrant, this is a child walking over the crosswalk, for instance. So that we can then give feedback and train this system how it should behave in certain situations. We could do this on real-world data, so on camera images, and label the data and provide this metadata. This is a common process called data labeling, but based on real-world data, this is very expensive, slow, with humans in the loop providing the right information. And for certain situations, this is not even possible. So for very dangerous or rarely occurring situations, we don't have real-world data. So we need to come up with a different way to provide this machine-readable semantic data to train the systems. In this case, what we did is to extract information from a global satellite data set. So we have a pre-trained machine learning model extracting all the building footprints, building height information, attributions like what kind or what type of object is it, what kind of building, what roof type, and so on. So the more data and the higher accurate data we can use to extract those things, the more accurate the result will be, of course. On satellite data, we have the big advantage that we can do it on a global scale. So we detected all the buildings on the globe, all the attribution, and in the second part, then we reconstructed the buildings in photorealistic 3D, as you can see it here. The big advantage of this synthetic 3D environment is that we know for every pixel at any time to what kind of object the pixel belongs, what kind of material it is. So we can export synthetic, already labeled and contextualized metadata to train camera systems, LiDAR systems, infrared sensors, and so on. Depending on the resolution, of course, this is applicable for different altitudes. So if we only use satellite data, we can't reconstruct a realistic 3D twin of ground level situations. For this, we would need to have fleet-borne imagery or high-res aerial imagery, ideally ground level captures, also capturing the facades if this is necessary for the synthetic data. As we are coming from Microsoft Flight Simulator, our 3D digital twin is very often used for aircrafts or flying objects in different kinds of altitudes. We can auto-generate also airports, ingesting vectorized data, and with our machine learning and artificial intelligence, the airports unfold into this synthetic environment as well. This is necessary, or we want and we need this synthetic data because imagine a car, an autonomous car driving in a city and is not trained for left-hand driving. We want to avoid this. Very often we don't even want to have humans if they are not trained to drive on the left side, right? That's tricky as well. So this labeling process is basically shortcutted with the synthetic training data because we can automatically export it. This is the big advantage here. There are other solutions as well, like photogrammetry. So like in Google Earth, which is a very good representation for our human eye and human brain. It looks very realistic. It depicts the reality, but it is lacking this semantic metadata, the contextualization. So it's not machine readable. That's the big difference here. And this is the essential part of the synthetic training data. Yeah, as we have the synthetic training data or the static globe, like cultural features and natural features, we can start to add dynamic aspects. If we add a strong wind component, then we'll see the movement of the trees here. Or we can then, of course, add other vehicles, humans, and so on to create as realistic synthetic training scenes and mimicking rarely occurring situations to make sure autonomous systems or a swarm of autonomous systems will react in the right way and as intended by us. So the biggest advantage here is, of course, that we can create synthetic training data for all kinds of situations, even if they don't occur in reality. We can say, what would it look like for the sensor if it would be like that, if the weather situation is like that, and so on. We can simulate all kinds of realistic scenarios. What you see here is based on the Unreal Engine, a game engine. Blacktrack is a spun of a video gaming company, so we have the right background here. And it's really fascinating how photoreal those things can be. Of course, it's always a trade-off between the real-time rendering, the photorealism, and so on. So depending on the altitude, the use case, and so on, this allows to generate the right synthetic training data in millions or billions of variations, because it's all procedurally based, all based on algorithms, meaning we can define what we want to see, what we want to mimic, and to export those things as synthetic training data. We need to be a bit careful here, though, that we don't mistrain the systems, because it's not reality. So we need to have a feedback loop with the real world, validating our synthetic training data. This is often done with a highly accurate 3D digital twin, 3D scan, and then manual labeling. And this can be compared with the entirely synthetically generated data. And by this, we can tweak and hone the data to, or as close to reality as possible. That's it. Thanks a lot.
All right, so for those of you that weren't able to access the link before, please click on this QR code and submit your questions if you have them. This will also be the same link that you can use for our other two sessions. The first question that we have is about what's going on in the terrain. So the question is, so what's more interesting is not necessarily the things on the terrain, but the things that are happening on the terrain. So what is your organization doing to address some of the variables that are happening within the simulation, like the political activity, military, economic, social, information infrastructure, time, et cetera?
Okay. So we focus on the static terrain. So we don't do the dynamic simulation. What we expose is basically the machine-readable terrain. With satellite data, of course, we can provide a daily update because it's fully scalable, the platform. So if we get daily updates from sensor data or drone data or whatever, we can basically press the button and provide an updated version of the terrain. We have tools to extract and to detect objects on the ground as well. So we have a no-code machine training environment, which allows anyone basically to train a custom machine learning model to extract features and to detect objects. So this is one component. So basically, if movements are going on the ground, we can detect that. The next step on this roadmap will then be to ingest not only static sensor data, but video data, basically, and then we can provide a live update. So this is one part of the answer. The other part is basically that we expose all the metadata, and typically our customers are simulating their dynamic scenarios on top of the terrain. Can be anything, right? So we expose all the attribution and so on, and depending on the use case and so on, our customers typically add vehicles, pedestrians, whatever, in a flying, driving, crawling, whatever manner.
Okay, so I'm going to attempt to take two questions and turn it into one question. We have a question coming in about the removal of terrain, and then we have a question coming in about the addition of terrain. So one question was, can you inject the results of 6 inches of snowfall? And then the second question is, what happens if something blows up and exposes what's underneath that? Like, are you modeling things that are happening underneath the terrain layers, et cetera? So I'm not sure if that's the same question or the same answer.
Yeah, I understand. So as our terrain is semantic, we support, so we don't do weather simulation, for instance, but again, we expose the metadata, and here we work with Unreal plugins, like Ultra Dynamic Sky, for instance, works out of the box, and with these plugins, you can simulate all kinds of weather conditions, like snow, and based on the type of underground, you can define how long this snow will last, and so on. To the second part, we have a collision calculation on the fly for the entire globe, and this then allows us to manipulate the terrain at runtime as well. So under the hood, we have a very scalable and performant C++ SDK, meaning we can simulate very long-range situations, and we can also manipulate the terrain at runtime if necessary. Like if something blows up, we can create the crater at runtime.
Okay, there's no chance I'm going to get through all these questions because there are a lot, so that's excellent. How do you determine the material of a given pixel that you capture?
Again, twofold question. So if we extract the semantic information from the actual sensor data, we have the models to say this is vegetation, what kind of vegetation is it, this is road, this is the land use, land cover type, and attached to that is the material. And the second part is if we procedurally reconstruct objects like the buildings, then we know also again, this is a concrete wall, this is wood, and so on.
Okay, so let's see. To what extent do you appropriately model materials within the terrain, say for a cell tower, and how it blocks various signals? This has obvious military reference.
We auto-generate, very manifold. So the building footprints are geospecific. If we have a DSM, we have geospecific height information as well. So this allows us then to do viewshed analysis and reflection calculation. And the materials on our auto-generated globe are geotypical, but you can always replace our auto-generated buildings with geospecific buildings, and if you follow our material specifications, then it will unfold or be aligned 100% to our globe.
All right, and then I'm gonna try to do a 3-for-1 question because I think I've got a couple that are. This is quite the skill, being able to aggregate questions like this. I'm gonna tell you. So, right, as I'm interpreting them, so I think okay. So I would boil this question down to, obviously you're taking imagery from above, right? And there's going to be some level of gap between what it is you capture and what's actually
Yes.
real, right? And if you're using this to help train autonomous systems, et cetera, there is undeniably going to be some level of loss there,
Yep.
right? Like, I don't know, water on grass, or I don't know, pick your various thing that you're not going to be able to capture. Like, how are you going to know that you're close enough so that your environments provide the sufficient amount of
Yep.
robustness and detail that they can do the things that you're trying to
Yeah,
advertise
yeah.
them to do?
So this is what I mentioned with the feedback loop, with the validation. Like with artificial intelligence in general, you need ground truth to be able to compare what is reality and what is the artificial intelligence creating, and is there a gap, or how big is the gap? And the same thing, or the same approach is necessary here. You need ground truth in order to be able to validate this. So you need a high detailed 3D digital twin area, which is basically a 100% or ideally 100% copy of the reality into a 3D digital twin. And then you can compare it with the auto-generated 3D digital twin. And then you have the gap in between those two things.
Okay, very good. Thank you very much.
Booth 3001, by the way. Please come by. Thank you.
Okay. Our next presenter is Pete Morrison. Pete co-founded Bohemia Interactive Simulations in 2007 and worked as CEO until 2013. He is now Bohemia's Chief Product Officer, coordinating product management, marketing, and sales to drive business growth. Pete is an evangelist for using cutting-edge simulation technologies to support training and operations. Before Bohemia, Pete studied computer science and management at the Australian Defence Force Academy. He previously graduated from the Royal Military College, Duntroon, into the Royal Australian Signals Corporation. Australian Signals Corps. He served as a Signals Corps officer and a project officer for the Australian Defence Simulation Office. Please welcome Pete.
Thank you. The Australian Signals Corporation is a good name for a company. So thank you, everybody. Pete Morrison. I'm here to talk about AI. I'm really glad that Hannes brought up Terminator. Has anyone not seen the Terminator? Come on, liars. No, it's all good. So in the Terminator, we have Skynet, right? Skynet is a sentient artificial intelligent entity that's intent on world domination and killing all the humans, okay? A fantastic protagonist and one of my favorite. Now, in the movie, Skynet sends robots from the future to the past to wipe out its inventor. And it's a similar trope that we see in many science fiction movies. Will this actually happen? Probably. The Fermi paradox, great filter theory, would suggest that this is a likely possibility. Why have we not seen intelligent life in the universe? The great filter theory says that advanced civilizations wipe themselves out before they get to interstellar space travel. Will this happen to us? The good news is I think we still have some time left, right? So what I'm going to talk about in this brief is the short-term future, the 5 and 10 years, and how I think that AI will actually help us, especially in defense. What could go wrong? Now, it's important to frame any discussion about AI because the term is so broad that it's become almost meaningless. AI could mean the little brains of soldiers in Call of Duty, a computer game, or it could mean like deep machine learning. I'm going to focus on the machine learning side, and I'm going to give you an overview and a Pete Morrison perspective on where we're going to go, specifically in the defense market. And I'm going to try and cut through the hype, and there's a ton of hype around AI to give you a grounded view and maybe some controversial takes. Now, where we are right now with artificial intelligence in defense it's actually quite difficult to determine because we're kind of limited in the unclassified space to the data we have on the internet and the media that has been published. Now, in Ukraine, we're seeing lots of footage coming out every single day of drones wreaking havoc on unfortunate soldiers on both sides. Okay? And as a former soldier, I do view these soldiers as unfortunate. We see drones kind of escalating in terms of capability. It started with drone drop grenades. It escalated to drones with flamethrowers and drones with anti-tank weapons. They're being used in all different ways. But not all of these drones are going to hit their target. And it's a one-to-one ratio, right? So a one-to-one ratio between the drone operator and the drone itself. But we need to remember that it's the infantry that holds the ground, not the drones. Who believes that drones have been a strategic factor in the results we're seeing in Ukraine? Who believes that drones have had this massive impact on the outcome of the battle? Okay, about half the room. This is actually debatable, and it's a really interesting point because I started out believing that because I was consuming all of this footage, mostly on Reddit, don't judge me, of all of this drone footage coming out from both sides showing these weapons being incredibly effective. But the failure and miss rate is likely very, very high. And we never see a video from a failed attack. And because drone video is actually the majority of what we're seeing coming out online, it kind of gives us this false sense of the importance of drones in this conflict. The front line is covered in Russian jammers. And some estimates are saying that the Ukrainians are expending up to 10,000 drones per month, and as many as 90% of these are failing to achieve their objectives. And like I said, we're only seeing the footage that both sides want us to see. So in some ways, drones are kind of like a propaganda machine for both sides. And like I said, it's really important to remember that it's infantry that holds the ground, not the drones. Now, I'm not downplaying the importance of drones, and I'm going to get to artificial intelligence in a minute. And obviously, they're a step change in many different ways, changing the nature of war. Tactical drones and anti-drone direct energy weapons are going to be a squad level asset in the very near future if they're not already. Your drone operator will be as important as your radio man. This is going to make the squad more effective, undoubtedly. But the real step change will come thanks to artificial intelligence. So how do we make drones a force multiplier in future conflicts? We change the ratio from one drone with one human operator to one human operator with 1,000 drones. We're already seeing this technology in everyday life. Has anyone seen the drone swarms for entertainment? The animated shapes in the sky? They're absolutely beautiful and they're great for entertainment, and they are, we see them at weddings and the like. If you're incredibly rich, you may have this at your wedding if you're lucky. And it's benign, right? But the risk here to both civilians and soldiers is obvious. It won't be humans from China that invade Taiwan first. It will be a massive swarm of drones that take out air defense and military installations ahead of the actual invasion itself. I mean, this is obvious. So autonomous drones will rely on machine learning for image recognition. This technology has rapidly evolved, paired with 3D data generated through photogrammetry. Okay? Now, these are the building blocks for fully autonomous drones. Autonomous drones will not need a control link with a base station. The control link is susceptible to jamming, and that's the problem right now in Ukraine. And the base station is susceptible to being blown up. The drone will use its sensors to see the terrain, and it will match the terrain it sees with the 3D data in its memory in order to navigate. Closer to the ground, it will use LiDAR sensors to not run into trees, and they won't need GPS to navigate. And they'll be fire and forget. Once the drone is released beyond the geo-fenced safe zone, it will simply kill anything that is warm and looks human. We don't necessarily need to invent new technology to achieve what I've just described. If you'd like to learn more, simply search for GPS-denied drone. You'll see exactly what I'm talking about. The UN refers to them already as lethal autonomous weapons or laws. It's not science fiction. If you can detect a sense of urgency in my voice, A, it's because I'm a bit sick, but B, it's because the more I've researched this stuff, the more worried I've become. The problem is the technology is readily available and entirely legal. Now, we can't build a machine gun at home. Well, I mean, you can, but you can't do it legally, right? We have laws against this type of thing. You can actually build an autonomous hunter-killer drone right now in your backyard as long as the airframe adheres to FAA regulations. You don't need to strap an explosive on a drone for it to be dangerous, right? These things fly at 40 miles per hour. If it hits you, you're in trouble. So within the next 5 years, I predict that we will have autonomous drone swarms. We may not know it, but there is no doubt in my mind that both we and our adversaries are incredibly focused on this right now. And I'm aware that US law currently prohibits a machine making a kill or no kill decision, but this will change because our adversaries will have no such restriction. And remember what I spoke about, 1 to 1,000 versus 1 to 1. We simply will not be able to win unless we change the way that we're fighting these wars. So what do we do about it? Well, we need to get on with it. We need to get on with it. The best defense against a drone might well be another drone. I can imagine other things like a turret with a directed energy weapon. That'd be pretty cool. Another idea out of the box, this is my CTO. So if the drone's trained in image recognition to see humans, you just pretend to not be a human, right? Do a crazy dance or something, could work. Keep that in the back of your mind when Skynet comes. So within the next 5 years, AI will have the most impact in the form of autonomous drones. But what will come next? And this is where it gets really interesting and I start to talk about generative AI. Ooh, excitement, I can feel it. Now, Gen AI will play a big part, right? And it's really, really incredible. It uses machine learning to create new text, new images, new music, and it does this through effectively learning patterns and applying those patterns to create new content, right? Fantastic technology. There's a lot of hype around this, and there should be. Gen AI will change our lives for the better. The mythical Babelfish. Has anyone not heard of the Babelfish? Oh my God, where have you been? Hitchhiker's Guide to the Galaxy. Absolutely worth reading. This is real. It's a device that you wear. I respect you, by the way, for being honest. It's a device that you wear that in real time translates between two people speaking different languages, made possible through generative AI. Fantastic. We will all have AI assistants doing our research. I had an AI assistant helping me with the preparation for this talk. We'll have AI assistants scheduling our lives. It's a massive opportunity for the human race. We're all going to become more productive. And it's going to be as big as the internet itself, almost undoubtedly. But for the military, I'm a bit sad to say that the utility could be limited in the short term. Gen AI needs to be trained on massive amounts of data. With both supervised and unsupervised learning, it's incredibly expensive to do this. We can easily imagine all of the wonderful ways that generative AI could help the military, right? Create me a story that I could use as a campaign plan at my command and staff college to train my colonels, right? Assess their performance. It's so easy to imagine all these things that the AI could do. But the effort to achieve this using the current Gen AI models would be cost prohibitive. The trillion-dollar question is when we'll see automated general intelligence, or AGI, but I'm going to assume it's a long way off, okay? I'm actually a bit of a skeptic on AGI. I do think it's a bit of a marketing gimmick right now, but I could be proven wrong. But for the purpose of this talk, I'm going to assume that there is not going to be this AGI that's going to come and save us or kill us. So let's define the goal, right? So as a former military person, I'm going to say that the step change in AI that I want to see is an AI assistant that can advise me as a commander on how best to achieve my mission. It's going to give me the preferred course of action based upon the situation presented to it. Now, first off, let's start with a platoon, right? So I was a platoon commander of a signals platoon. Who else here has been a platoon commander at one stage? Okay, fantastic. All right, so you're a platoon commander. Now, let's imagine that you have a device, okay? A device, it's your mission command system of the future, and it's AI enabled. Let's imagine that it knows the position of all of your soldiers. So all Blue 4 entities, their positions are known. The soldiers have an instrument on their rifle that they can use to designate enemy positions. So the device the platoon commander has knows the position of enemy forces. You as the platoon commander have an autonomous drone circling overhead that's automatically registering the position of enemy combatants, okay? Automatically. And it's fighting other drones. You can kind of imagine lasers and stuff. And then at the same time, it's scanning the terrain. So it's taking photographs, which it's turning into 3D data and feeding it to the tablet. The tablet all of a sudden has the position of all friendly and enemy units and a 3D map that it can also use. And so just like in a computer game, we can ask it questions. Give me the concealed route to get the hell out of here. Give me the best position for my machine gun and its arcs of fire to place suppressive fire down on the enemy. Now that would be truly useful as a platoon commander, okay? That would be truly useful. That's not that far away. I would say within 5 years. The technology I've described is mostly all here. The real hard part is getting the position of the enemies correct. Right, so that I think is exciting. Now at the division level, let's go all the way up. I left the army long before I got anywhere near a division. In fact, Australia, I don't even think we have a division. The Australians in the room can probably correct me. But at the division level, recommending the best course of action is the Holy Grail, the absolute Holy Grail, right? But this is really challenging because of the garbage in, garbage out problem. That phrase was actually coined here at IETSEC, I think like 13 or 14 years ago. There was a paper on it. And that's just as true today as it was back then. Now at the tactical level, there are tens to hundreds of participants, but at the division level, there is thousands. And the number of weapon systems and weapon platforms and human beings is kind of unbounded. So at that kind of level, the simulation begins to break down because the data that's going in is inaccurate. Now, ideally, the mission command system at the division level is aggregating all of that data from the lower levels, right? That would be cool. But you're still going to have issues. You need to account for logistics, and you also need to account for subjective factors like morale, okay? So the simulation is not going to be accurate. And this is the real tricky problem. It doesn't really matter how smart the AI is up there at the division level, the data isn't supporting good decisions. There's an interesting article by James Lacey, right? The article's titled The War Game Before the War. It describes a war game conducted by the Marine Corps University just 2 weeks before the Russian invasion of Ukraine. Now the results were similar in many ways. The war game ended after the Russians had retreated from the north and begun their slow advance from the east. But the value of these war games isn't necessarily that it's predictive. The value comes from the discussion around the results, right? That's when war games become really, really interesting. And James Lacey himself warned that one must be very careful when using a war game for predictive purposes. And this alludes to the danger of AI and simulation in general when simulating courses of action. So that's just some food for thought. So for these reasons, I see a truly viable AI surrogate commander as being a long way off, okay? Unlike the other step changes like autonomous drones and tactical mission command, AI advisors at the higher echelons will really struggle for the same reasons that humans do. The lack of perfect information about what's going on, and also the asymmetric nature of war. One of my favorite quotes from Admiral Nimitz: "The war with Japan had been reenacted in the game room. Nothing that happened during the war was a surprise except the kamikaze pilots. We'd not expected that." So to summarize, we will see autonomous attack drones in the very near future. And I do believe that the idea of AI assistance to tactical commanders is very close. We're kind of lifting technology and algorithms from computer games and marrying that with what's available today. AI assistance at the higher echelons will take longer, but there will be tools available to help staff much sooner. That's the good news. We can imagine generative AI-powered agents monitoring radio traffic, auto-generating reports, automatically creating supply requests based upon what's happening on the front lines. All of this is easy to imagine. But when will Skynet destroy the human race, right? Let's get to the most important stuff. Now, I personally don't see AI as any different to any other technology that humans have come up with, right? It's a little bit scary at first. Oh my God, those cars. We can't go that fast. We need to ride horses, right? I do believe that we're going to harness AI and make it work for us. Now, bad people will build bad AI, right? But good people will build good AI to counter the bad AI. Hunter-killer drones will have drone hunter-killer drones, okay? You can guarantee it. There'll be like a kind of arms race. Now, AI represents a massive opportunity for defence and effectively to better prepare those who protect us. I'm really excited about this domain. I need to make the point that we are a little bit specialist, okay? So, you know, what they're making, the ChatGPT guys are making, you know, what Google's making, it's for the masses. We're a bit niche. So there is going to be significant investment required to generate the data needed and create the algorithms required to make our AI work within our industry, but I'm looking forward to that. So that ends my talk. Thank you very much for your attention.
All right, thanks, Pete. Already have some questions from the audience. There is still time to post if you are interested in asking a question. The first is about countermeasures. What sort of countermeasures to AI do you see in the future, and how is AI going to handle them? So examples are like people dressing up as cows, or dressing tanks up like boulders, those sorts of things.
Yeah, so that's the most obvious solution, but the problem is that they're feeding the images directly back. So as soon as a drone has seen a thing once, that thing can't be used again. Direct energy weapons, being able to kind of fire an electronic pulse at a drone, knocking it out of the sky, I think that's going to be a really big one. And yeah, drones, hunting drones. So it's going to be an arms race, effectively, a big arms race.
Okay, my next question. How might we be able to collect low-level or ground-level data in denied environments, and might there be a suitable substitute?
Oh, good question.
I agree.
Yeah, it's going to be really difficult, but I mean, I think like the air will be just filled with buzzing drones, like, you know, and you only need 2 images to create a 3D representation, and so, and it can be taken at different altitudes. Obviously, resolution changes depending on the altitude that you're taking the photograph, but I just don't see this as a problem. I mean, I just think you're going to have these autonomous drones taking images. Even if it can't transmit those images, it'll fly back and deliver the images. So I think that in future conflicts, every inch will be mapped out in high fidelity 3D. Maybe we just need to keep digging deeper holes.
We talked to our friends at Blackshark, who just gave a great presentation.
True.
Okay, tactical autonomy requires logistics and provides logistics. To what extent will tactical autonomy provide direct logistics assistance to human robotic systems in the field? And how do you believe this burden will be mitigated by other autonomous systems?
Well, I didn't even think about that, but yeah, I mean, it's going to be like Amazon for the front lines. And I think it's actually a very obvious use of autonomous drones. And I mean, that's got to be less than 5 years away. Drone-delivered ammunition sounds like a great way to solve some of our problems we have right now.
You say that. I have not yet gotten a drone-delivered Amazon package.
That's because of the FAA. It's not because of the lack of technology.
Yeah, sure. I was promised.
Blame the government.
Do you think a Gen AI assistant could assist a commander with a course of action brief? If so, what do we need to get there? Yeah,
so assist, yes, but I mean, I'll give you an example right now. Like, generative AI is really bad at like geolocation. You know, so it can create stuff from nothing. Like, it could create it could fabricate a story, like I was describing, but and maybe it can create something that's 50 or 60% all the way there based upon the right inputs. But there's still going to be a lot of manual labor to bring it into line with what's needed. You know, you need to do like 10,000 of these things, 20,000 of these things, and then if you have humans correcting the results in order to train AI for that purpose. And I think it's easy to be naive about what Gen AI could do because it does so many things so well. I mean, I pumped my brief back into ChatGPT. Don't tell my boss, I wasn't supposed to do that. And it gave me a much better version of my brief. But I didn't want to use that version because it sounds like AI wrote it, So I think we have a way to go. But we need to focus on the problems we're trying to achieve and then figure out how to train the AI to do that and if it's even applicable. It's the why comes first.
How you feeling, by the way? There's more questions coming in.
No,
I'm good.
I'm good. I'm on the best drugs, man.
Okay. All right.
Not contagious.
You mentioned thousands of drones being used at one time. Do you think that the expense is worth the effect?
I guess we'll see. I mean, I don't think you'll have a choice, right? Because, like, you know, there is an adversary that right now has all the factories, and you know they're going to be pumping these things out. And I mean, you can create one of these things in your backyard right now from parts you order on the internet for less than $50. I know there's probably people in the room that have done it, and so I mean, I actually don't see it as a significant expense compared to a $1 to $2 million missile. So I actually that's the concern. We kind of have to figure it out. We don't really have a choice.
Okay, I think we'll call it there.
All
Thank
right.
you very much.
Yeah, thank you, everybody. Yeah, sorry.
Okay, and again, for those of you that use the link for questions of our last presenters, you can use that same one. Just go to the next talk and post your questions there as we go through. Okay, our next presenters are. Let's see. Where am I? Thank you. Sorry about that. Okay, our next presenters are Erica Dretzka and Jordan Gottlieb. Ms. Dretzka is a seasoned data scientist with over 20 years of experience in various industries, including insurance, I did not know that, energy, national defense. She has established 2 data science teams inside the Department of Defense and led the development of advanced AI and machine learning algorithms focusing on employing engineering-based methods to design the optimal reference architecture and bridge strategy to support AI and data-backed mission support at the scale and resilience required for the DoD. Mr. Gottlieb is passionate about applying innovation and collaborative techniques for strategic synergies to unify stakeholders across an enterprise and create a data interoperability model across all of industry. He's currently focused on defining and implementing an interoperable data environment, as well as defining an actualized zero trust model that is complementary to current cybersecurity capabilities. His broad background includes system engineering, program management, strategic planning, business operations, government acquisition, and executive support. He holds a bachelor's in computer science, mathematics, and mathematical physics, an MES in computer engineering, master of science in computer science, and an MBA with a concentration on international finance. Please welcome Erica and Jordan.
Hello. So actually, the last 2 talks were great lead-ins to what we're going to talk about. So we're here to talk about data mesh and zero trust. And Jordan and I have been working on these for multiple years now. So yeah, I mean, Hannes mentioned something about having to label your data. This is something that is a very massive investment that DoD is doing. And we believe that what we're about to present to you is going to be a tool that can make that more cost-effective and sustainable. So yes, why a protection posture for ModSim and training? So this, obviously, we're here talking about something a little bit more architectural, data mesh, zero trust. And some of these things have been around for a couple of years, but they have been highly theoretical to date, meaning there really hasn't been much of an implementation plan behind them. Now, one could argue that out on that floor, there's a lot of data meshes that are operating, data fabrics, and we're not arguing that. We think that's probably very true. But what we need is to make these things able to interoperate with each other at scale. So when we have these networks that are operating and we say, hey, we need to put together an exercise, we're basically creating another data mesh. So what we've done is we've come up with 15 different services and microservices, which we think are non-negotiable components of the data mesh. And then as we were talking about zero trust, where Jordan is stationed in CIO, we realized that these, if we just take parts of what we had put as the 15, they pull together a zero trust solution. And actually the Zero Trust Office agreed with that to the point that they actually funded a couple of microservice prototypes out of ADL and DHS Border Patrol. So very interesting stuff that's happening. We need this all to be scalable. And and this is where it gets kind of interesting, it has to be resilient to vulnerabilities. We need to be able to understand the sensitivities that are embedded inside of whatever are the systems. One might be that they have a bunch of PHI. Another might be that we have 5 different vendors with IP that, we want to protect that IP, right? So now I'm going to layer in one more thing, and this is where it gets to be the next big thing, right? Quantum computing is a big, big challenge that's about to hit us. It's estimated it is going to be viable at scale by 2029 or by 2030. So this is a really big point because we have been relying on encryption algorithms that were developed in World War II. And they have been awesome, they've worked, but now with quantum computers, this is the first technology that is estimated or projected to be able to break those algorithms. So therefore we propose these 15 services, and Jordan is going to talk to some of them, the ones that we think are effective for Zero Trust.
Okay, so I worked with Erica for 3 years on data mesh, and then I shifted over to Zero Trust Office. And the first thing I discovered was Zero Trust was not understood by almost anybody. And most of the doctrine is, in Jordan's opinion, because I can't say officially it's wrong, but in my opinion, most of the doctrine about Zero Trust is incorrect. It's really cyber doctrine improving cyber hygiene. The fundamental difference is, and a colloquial expression is, cyber defends the infrastructure. Zero Trust lets you in the front door to that infrastructure. And if you think of that model, the conversation is much easier to manage. When we talk about Zero Trust, and again, this is a simplified model. You have identity management, you have role management, and you have attribute management. Identity is the actor, and an actor doesn't have to be human. It could be autonomous. It could be a drone, actually. The roles, and this is a shift, roles are the things with permissions and authorities to do things. And so the first shift we have to do in the culture space is getting actors assigned to roles, not giving actors direct privileges. And so that's a big shift in everything we're doing. And then the attribution of every object, and I say object is object, asset, resource. Resource, think big computer. Asset would be like a router where you're going to engage it, but you don't call it directly. And an object is something you interact with directly, like a file. So when we get the identity, now assigned to a role, given access to resources, assets, and objects, you now actually can manage access control properly and down to the finest grained field you need, like literally one field, one value in a database. You can specify that if you have all these attributions done in a business rule. So that, once you have that, I can now guard the front door and let you in or out, and it becomes a binary decision. I either know you, trust you, and you have access, or you're not getting in, and it's that simple. Once I let you in, cybersecurity takes over. So you have to do both at once to get to a protection posture. So we're no longer just securing, and we're no longer just controlling. We're now really protecting everything. Next slide. So, unique identifiers. This is different than your UID, GUID, or W3C DID. Those are web-focused identifiers. This is meant to be a generalized asset inventory control. It's hard to say that fast, by the way. You can track anything. It doesn't have to be a digital asset. You could track a piece of paper in a filing cabinet using the UID model. That's exciting because now I can target instance of anything. Couple that to control vocabulary. Semantic congruence, or understanding the exact definition of any data container or label or alias, as it were. That is where we have a lot of miscommunication, computer to computer or human to human. So the control vocabulary solves that problem by using semantic tokens that are mapped to a definition. The tokens are not intended to be human usable, they're still human readable. But we want the humans to use the alias in their local context so they don't have to change anything they're doing, and they just map to this now authoritative definition so everybody can speak their language, but now we can intercommunicate with pre-mediated data, meaning somebody says this is a horse and somebody says this is a stallion. I know it's both horse in that general sense, I don't have to go through 40 conversations or run 3 algorithms to figure it out. So control vocabulary actually enables that type of semantic congruence. Next slide. Okay, so next piece, and I'm going through the 4 fundamental pieces of what we think builds a data mesh, and there's the other 11 that allow interoperation. A federated data catalog. The current catalogs, and there are a couple out in the market that are graph-based, but the current catalogs that are traditional database or horizontal database, they scale out because we're going to have trillions of entries in this thing, and we just can't do that in a typical database. Even with sidecarring, you can pay $100 million and get another billion things attached, but it's still not good enough. Graph has the ability within computer limitation, and you can do, gosh, back in the 60s, paging algorithms. You can graph infinite space. And it's just an edge connection, so you don't have to do a lot of fancy algorithms. Federated data cataloging is going to be able to track anything and attribute it any way you need it to do, so you can go find whatever you need through basically simple word querying, and it'll traverse the catalog near real time and find the object you're looking for. And it'll have every other object it's connected to in one step. So that's a huge advantage. We need a federated data catalog, and I'm not saying traditional databases won't be used to optimize and accelerate the massive graph catalog, because that's actually how one of the prototypes did it, to get real-time response. After that, you get bills of material. Think of this as a shopping list when you go to the supermarket. It's really that dumb and simple. It's just your shopping. It's your characterization of everything you need to know about what you're going to do, the object you're talking about. So you can get 3 types. Atomic characterization is about a single object. Composable, think of assembly subassemblies, and that uses atomics or other composables, so you can start building systems through control vocabulary so everybody knows what you're building. And the last part is extensible, and that's where you get process-driven or business modeled bills of materials that use the atomic and the composables. So given those machine readable, and much more important, because I consider machine readable the new low bar, it has to be machine comprehensible as well. And that's the new key. The machine has to understand what you just gave it. So when you get the bill of material, reference in the data catalog, using control vocabulary, and you can track the asset, you now have the foundation to build an interoperable data environment. And so that interoperable and data environment doesn't depend on context anymore, because it's all characterized in your bill of material. You can figure out, does this widget work in my context? The definition says no. I move on to the next one. I don't have to go reach out anymore. It's all machine comprehensible. Next slide. Policy access control is digitizing human written policy, and eventually we may have machine generated policy that builds the access control rule sets. And that's important because when you start talking about zero trust, that's basically what zero trust is. It's a rule set of access control. So you want digital policy to be, again, be machine readable, machine comprehensible. Digital policy administration, these are the tools that we're going to allow authoring of digital policy. Those are not quite as prevalent as we need them to be. The typical person can't author rules. You need a rules engineer using one of the tools, and today they're complicated. We are seeking English-like regular expression rules engines, which means you can give this to a functional or an operator or a typical person, and they'll be able to say, I don't want the dog out after 9 o'clock, and the rules engine will structure that into machine-readable code. Right now, I've got to get an engineer who understands how to code that in the rule language, so it's non-trivial. The last part is, for DoD, data security classification. Jordan's opinion. That's an attribute. It's secret, it's top secret, it's public domain. That feels like an attribute. The department wants it to be special, so we've said, hey, if we're going to have data classification, we're going to build a nice box, we're going to paint it gold and make it shiny so it feels important, and then we're going to say, follow the exact same attribution process you do for everything else, just focus on data classification or security classification, and then the machines will be able to consume that. And so I won't be able to give Erica something she's not read onto because her role and her name won't be attached to that classification tag. Next slide. So, here's the big vignette, and this is a real vignette. I'm not going to say who did it, but this was a live vignette that's actually happened in the department, and I built this to discount, probably shouldn't do this in public. FlyingSpeed was just declared zero trust. And my first question was, great, do they interoperate with everything else in the world? And they said no. I said, then it's siloed zero trust. It's not zero trust, it's siloed zero trust. We need to be careful how we say this. And the answer is, but they work with all FlyingSpeed things. I said, that's great, that's a silo. Because the Army doesn't use FlyingSpeed for everything, so it's not zero trust everywhere, and zero trust has to be everywhere. So this basically has an actor from a community using a different community's data with another community's tool using a commercial product and another commercial pipeline. All of a sudden, I need everything talking to each other to get zero trust to work, and I've got to be able to protect the data. And so in order to do that, zero trust has to be everywhere. And so now we hit all the way back to the start of the conversation. Machine comprehensible, machine readable, and I don't want to have to make 15 phone calls to know how to do it. So I need the XBOMs and the data catalogs to be able to queryable so that I can do this by myself, or maybe in the future have AI just do it for me. Next slide.
Okay, so this is what we're calling data mesh origami. Anybody who's done origami, and I was terrible at it, I always wanted to be good at origami, but maybe this is where I shine. So these are the 15 services which we have proposed. Those that are bolded and italicized are the ones which are the ones that Jordan just walked through. So if you think about playing origami, you can use the data mesh for probably 100 different uses. It's just how you combine what. So right now we're looking at the zero trust problem set. Another problem set would be data quality. Maybe you just open it up differently. Or maybe you open up a third way to get to transport layer and APIs and access denied environments, and how do we transport data in that way. So we put all this together and hopefully that's a fun little graphic there. It's like an OV1 for origami. So like tying this all back, in order for us to be telling everybody on the floor right here that we need to use your system in, maybe it's a friendly ally like environment. We need to be able to have these things work in these different environments, no matter what the sensitivities are that are inside of those environments, right? And so that's why right now we're doing a lot of that manually. They're doing like point-to-point connections. They exchange data dictionaries, and many times in real time they have to consult a SME to say, hey, wait, what was that what does this mean? I just received this over the airwaves. So what this proposes to do is to digitize that process and make it something that's scalable and safe. So that is where we think, especially when you consider quantum computers coming on and their abilities that are going to be far outpacing what we have right now, this really proposes a good future for us if we can pull this off. And by we, I don't mean Jordan and me. I mean all of you guys out there, everybody on that floor, and the people who aren't here, whom you guys are representing, right? So if we can all carry that message, we need your input. We need you to help us figure out how to do it all. So that's all we got. Oh yeah, next slide. There we go. That's how you get in touch with us. Okay. Yeah. What's that?
I'll stand next to you so we can handle questions.
Oh yeah, we can get out of the way of this QR code.
I have the first question.
Sure.
So when I hear zero trust, access control, et cetera, I can't help but think the first thing is that, oh my gosh, this is a giant pain in the ass. Like, where's the super user ID, right? I don't care about all this access control. Just give me the sudo command to just because I want to see all this sort of stuff. Is there an analog in Zero Trust? How do you deal with that? Like, are we just introducing a new password system that everybody's going to hate with this, or what's the difference there, and is that a thing that you can manage?
So, no, there is no super user password because that defeats Zero Trust.
Can you make one for me, though?
No. Can we manage it? Yes, because Zero Trust is rules-based. I can build override rules. And so a classic example, and we have a lot of warfighting communities come and say, look, when bullets are flying, I do not want to wait for my system to process. So I joke and say, the commander's F5 key says, look, it's hot. All rules are turned off right now. When it's done, he hits F5 again, and all Zero Trust comes back into play. So we can rule manage this dynamically and give the warfighter or any other critical service function the ability to say, I'm going to limit, I'm going to diminish, or I'm going to eliminate for the time being. What you don't want to do is say, you are now a super user and you can go screw with anything in the system, because that defeats the purpose.
And as that happened, a new one came in that I think it has a little bit of relevance. So how are you actively addressing challenges in adopting Zero Trust, such as cultural resistance, the absence of policies, or budget constraints?
You want to take it or you want me to?
You're the one in Zero Trust.
Okay.
That's your.
So culture shift is huge, and it's a challenge. And so what we're doing is we're getting small communities of interest together, and these are operational communities as well as we'll call it technical communities, to consider how they would inject Zero Trust into their operating scenarios. The ZT office has, I think it's 11 pilots running to do specific experimentation on getting ZT to be not only demonstrable but practical. A hard challenge is the OT, or the operational technology community, which basically has closed systems or control systems, and we have active pilots right now working on that to say, look, you're really just a system. We know you're a special snowflake, we got it, but you're still a system, and a system can be access controlled, and your system will benefit by having broader ability for data exposure if it's managed and regulated properly. So you now get the benefit by having everything access controlled and regulated. You're no longer having to draw that physical solid perimeter to say it's the only way I can be safe. So we're working on that in the Zero Trust office. DHS has other adoption into, and they're working both data mesh and Zero Trust coincidentally. And so it's hard, but it is possible. And so we're breaking down barriers in very small communities, and we're building momentum that way.
Awesome. When might the CDAO push ZT? Is that the hip way to say Zero Trust?
No, so the DoD CIO ZT PFMO. It's defense.
I just want to know what I can
It has
use.
to be an acronym.
When will the CDAO push ZT as a contractual requirement to industry?
Ooh, okay. Yeah, so I'm not on the acquisition side of the house. There's a lot of effort. We just actually stood up a cyber office, and going back to the previous question, I would layer in there that there's a misunderstanding of what ZT is and what data mesh is. And so there's a learning curve that everybody's going through, including our organizations. So if we are going to dub cybersecurity as one of the things right now, there are efforts to work with the acquisition side of the house to say, hey, we need to understand certain things about a system. Now this is where ZT comes in, because we want to say, not just give us the configuration of your system, but also we're going to protect that. And so that's really where this back and forth is very important. I wouldn't say the CDAO is really pushing ZT, and that's not nearly on the horizon right now. But they did allow us to come talk together. So I think they acknowledge that there's some we're going to do it
And we
eventually.
have seniors who, again, I won't say principals, but we have seniors that are actively collaborating about, you need to tell me what you're doing and you need to tell me what you're doing so we can stay aligned. So the reality is there's a NSM out for zero trust mandate, and there's another NSM for data mandate, and when you start gluing those together, you end up with data mesh and zero trust naturally being the next level of, you have to do them together. So that expectation is coming, and then the policies will follow.
All right, Jordan, since you were talking, I'm gonna give a Jordan question, then I got two Erica questions coming behind that. So, okay, so doesn't zero trust still depend on encryption? Wouldn't quantum computers still be problematic for zero trust?
So the answer is, if you use traditional encryption for zero trust, yes. The real answer is, we're not using encryption for zero trust. We have different architectural techniques, UID and then CCVID, which is another numeric token in a separate managed space. They're dumb numbers. And so by transiting in dumb numbers, I don't need to encrypt the dumb numbers. You have to now have access to the back channel system when we re-architect stuff to say, if you can't get into the secret sauce system, you got a dumb number. So I actually had an AI guy call me and say, look, if you give me 1 billion transactions, I'm going to still pattern generate. And I said, fantastic. Now I'm going to Diffie-Hellman every single transaction individually. He said, why are you doing that? I said, because I just screwed you. So Diffie-Hellman is a time-sequenced encryption locking technique. So every single transaction will have a unique combination number for that one dumb number. That dumb number will now have 1 million permutations, so it breaks the pattern.
And if I could just add one more thing to that, and there is new technology that's, maybe it's not super new, but privacy enhancing technology. The US has not been very strong in this. Our partners over in Europe have been using this extensively, right? I see some nodding, yeah. The UN's using it. Estonia is for all of their, I mean, we all know that they are a highly digitalized society, right? They're using PETs, these privacy enhancing technologies, and there's probably, the White House does have an effort behind it that I've been a part of. They're calling it privacy preserving data, SA, can't remember what SA is. But yeah, so there are these, and those are currently, that they've never been broken by a quantum computer. So there are new encryption methods that are on the horizon to help.
Okay, can you go over one more time how the data catalog works? Is it a classification system assigning the role as attributes to the data itself, or something else?
Okay, so right now it is a tabular database. Now, I mean, think about, and of course we're talking about wanting it to be graph, but think about every intersection of row and column as having its own protection inside of it. Right now that's not the case. Right now you get access to some subset of a dictionary. But that's where the proposal for Zero Trust to assign privileges based on every single data element that is out there.
And the catalog itself would work like any other catalog function. And so the query mechanism is fit to the structure holding mechanism. So if you have a horizontal database, you're using a key index. If you use a vertical database, you're using a key term. If you're using a graph, you're using a node index. And so it doesn't really matter what your storing structure is for other than scalability. And so the catalog will work exactly how you use catalogs today. They'll just hold all this information, and depending on how you structure it, it was interesting. One prototype did it one way. They put every single graph node property, which is how you characterize a specific node, as a graph node. The other one used an alias, put a key term in, and then put all the properties in the node. And those both work just as well. It's just a different way you traverse the graph and the graph space. So.
Okay, we'll do one last one. So in this new system, if a user doesn't have the role to access the data, can you go over the process on what stops them from sharing the data? Does the original person with authorized access not able to send it, or will the user just not be able to see or access the file?
So I'm going to do this with a house analogy because it's really easy. You don't have a key to my front door, you're not getting in my house. If you break in, my alarm's going off. So I'm not giving you access. If you're not in a role, you're done. And literally the business rule architecture of IBAC, RBAC, ABAC is sequential intentionally. So if I don't know you, I'm not going to talk to you. There's not even a thought about a role. I'm done, I will clip the conversation. If I know you and you don't have the right role and you're asking for something that requires that role, I may be polite and send you a nice note saying you're not role authorized. Knowing the department, they're just going to stop the conversation. If I have identity and role and I don't have access to the computer and the data is housed by that computer, we're going to stop that conversation. So you don't see anything because you don't even get to it. So there's no risk of, well, if I'm not authorized, can I send data? You don't even know the data's there.
And then just like one other aspect to that is you can't share it to an unauthorized person because that's where the roles, the identities, the attributes, if that person doesn't match up or that entity, be it a drone or something, doesn't add up or match up to the right combination, it's just not going to happen.
The two technologies that we often talk about are data loss prevention and digital rights management. This actually is an implementation technique to achieve both of those, both within your boundary and external. And the external one is a little tricky because I have to certify, and there are techniques to go do that, you're ZT compliant with my ZT expectations, and if you're not, I stop the conversation because it's like the front door. I don't want to give it to you, it's too risky. If you are, my expectation by agreement is your zero trust system will protect it, so DLP and DRM are preserved even outside of my community.
Okay, thank you to you both.
Thank you.
Okay, at the beginning of this session, I mentioned at 17:45 there's going to be a Next Big Thing social. We have recently discovered that social requires physical tickets. We do have those tickets, so on your way out, if you're interested in showing up this afternoon, lovely Maureen behind us waving can hand out your tickets. Also, I have some at the front if you'd like to see me for those, but looking forward to seeing any of you that are interested at the social this afternoon. Okay, thank you all for coming.